Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about perimeters and areas of similar figures. We're going to be looking at different shapes today, and we're going to be talking about how perimeters and areas are affected and how they are similar in these figures. We're in the Common Core Math Standard, Geometry, and today we're going to be roughly talking about creating and describing shapes and their figures, especially with their perimeter and area. And our guiding question we're going to ask ourselves is, how does the size of a shape affect its area and perimeter? If I double a shape's size, what does the area do? And what does the perimeter do? Let's look at it. Well, here's a picture of a square. Oh wait, not just a square. That's me playing Foursquare. That's me back in the day playing Foursquare with my college buddies, and we loved it. And what we would do is we draw this Foursquare court. No matter where we would go, we'd bring some chalk with us and a Foursquare ball, and we'd set up this awesome court. How might the court differ from different times to different times? Well, what would the perimeter look like? What would the area look like of this square? And how might that affect my game? I don't know. It's pretty sweet, isn't it? All right, well, what's the difference? If we take a shape and we find its perimeter area, what happens when we enlarge or shrink that shape? Well, let's see what kind of patterns pop up. Here's our first example. We're going to find the perimeter area of this object when we multiply it by 2, 3, and 4 times as big as the original. So here's the first one on the left. Notice we've got dimensions of 1 by 1. So the perimeter there is 4, right? That's easy. 1 plus 1 plus 1 plus 1. And then you've got the area of 1. Well, 1 times 1. All right, so let's take that shape and multiply it by 2. Let's double the size. So now the length here is how much? Right, it's 2, and the width is 2. So the perimeter, what's the perimeter and what's the area? All right, you got it, right? So perimeter is 2 plus 2 plus 2 plus 2 gives me 8. And then the area would then be just 2 times 2. Okay? Good. Now what happens when you take this original shape and make it 3 times as big? Well, instead of being 1 in the length, it's 3, and the width is 3 there. So then it's, for the perimeter, 3 plus 3 plus 3 plus 3, or 3 times 4. And the area then would be 3 times 3, which is 9. Pretty basic, right? All right, why don't you do this big one by yourself? All right, what'd you get? Did you get 16 and 16? Same dimensions there. Pretty cool, huh? All right, now, have you found any patterns yet? Have you thought about how you go from the perimeter? When you double the dimensions, what happens to the perimeter? When you triple the dimensions, what happens to the perimeter? And when you quadruple the dimensions, what happens to the perimeter? Okay, that pattern's pretty easy, right? You just take 4, multiply by 2, and you get perimeter. Take 4, multiply by 3, you get 12. Take 4 by 4 times as big, and you get 16. Now, the area, not as easy to recognize. And that's what we're going to talk about here in just a bit. But did you figure the pattern out there? If you did, that's great. Let's move on. All right, why don't you do this with these guys? Find the perimeter of the area of the new object when it's doubled, tripled, and quadrupled from its original size. So this is a triangle. So remember, the area of a triangle is 1, 1, and 1 for the dimensions there. Area is B, and I'm just telling you it's B. Okay? So here, for example, how many B's do we have? We've got 1B, 2B, 3B, 4B. So what you're going to do there, instead of writing the actual area, you're just going to write 4B. Okay, so for the A, you'd write 4B. Perimeter here is 1 plus 1 plus 1, so that's 3. Here it's 1 plus 1 plus 1 plus 1 plus 1. Okay, so you got it. Why don't you do the rest of them? All right, did you have any trouble? Biggest thing here, I think, is with the area. If you call the area B, if this area, the green space right here is B, here you have 4 B's. Here you have got 4, 5, 6, 7, 8, 9 B's. So area there is 9B. And then can you figure out what you get here? Did you get 16? Yeah, you should have. All right, so here we go. All right, well, with this rectangle, let's look at it. We've got an area of 2, perimeter of 6, okay? Now, when you double it, what happens? You double the size. What happens when you multiply both sides by 3? What about when you multiply each side by 4? What happens there? All right, now what happens with the parallelogram? Notice any things different here? Just say that the area is C, because I didn't give you the height of the parallelogram, but the perimeter is 4, right? 1 plus 1 plus 1 plus 1. So the perimeter is 4. Area is C. We're just going to give you that letter. I'm not going to tell you what it is. What happens when you double the sides? So instead of 1, it's going to be 2. 1 is going to be 2. What does the perimeter do? When you multiply by 3? And when you quadruple it? You picking up the pattern? I bet you are. All right, so what's the pattern here? Can you fill in this chart? Let's take it. When we get a square, we multiply it by 1. That's the normal size. When we multiply by the perimeter, all you're doing is taking the perimeter and multiplying the perimeter by 2. So it's 2 times there. And then when you triple it, it's 3 times. And same thing with there. And if you hadn't figured out the pattern, you multiply the perimeter by the number you multiply it from there. So we started out with 1. How do we go from 1 to 2? Multiply it by 2. So you multiply the perimeter by 2. So all of these down here are going to be multiplied by 2. And then when you triple it, multiply it by 3. Quadruple it, multiply it by 4. Now the area was a little different. Multiplied it by 1 time here, but then it was 4 times, and then it was 9 times, and then 16 times is big. And did you notice that was the same pattern for each of them? Well, it was 1 time there, and we multiply it by 4 each time, and then 9, and then 16. How do you get 4, 9, and 16? Well, how do you go from 2 to 4? How do you go from 3 to 9? How do you go from 4 to 16? Can you figure out what operation I'm using? All right, well, here are your answers if you want to fill them in there. Okay, well, ratios between similar figures is pretty easy. As if you haven't seen already, the perimeter, you just double it when you double the lengths. When you triple the lengths, you triple the perimeter. That's really easy. Now, it's different, though, when you get to area. Here's the trick. It's squared. Remember, how did you go from 2 times here? It was 2x, and it was 4x. You square 2, you get 4. Square 3, you get 9. Square 4, you get 16. All right, so here's some formulas. If the figures there, we look at the ratios of perimeter and area. Here's what we're going to do. With perimeter, the ratio is just the length of the side of one compared to the length of the corresponding side of the other one. So originally we had, a length of 1, and then we doubled it, so it was a length of 2. So it is a ratio of 1 to 2. All right, but with area, it's a little different. You actually have to square it. So the length here was 1, the length here was 2, but then you have to square what's inside. So it's 1 squared over 2 squared, which ends up being 4 times as big. Let's put that into practice and see what happens, okay? Let's look at this one right here. We'll do this one together on the left. 8 to 3. What's the ratio of the perimeter? Well, we take the one side 8. Okay, so we take this 8 here, and we take the 3, and all we're doing is comparing it. We're just finding a ratio between the two. And all a ratio is comparing it. So if the perimeter is what's normally there, it's just 8 compared to 3. That's the ratio. You're going to be finding the ratios between the two numbers there. So we have 8 to 3. All I did was take this side and compare it to that side. No big deal, right? But with the area, it's a little different. We take that same ratio, 8 to 3, and we square it. Now, how do you do that? Well, it's not too difficult. All you do is take the 2 there, 2 there, and it becomes now 8 cubed, or squared, to 3 squared, and you get 64 to 9. That's the new ratio. That's the new ratio. So if we look at it, if the area here was 64, the area here would be 9. Right? If the area here was 64, if this was 8 by 8, this is 64, this area would be 3 by 3, and it would be 9. So if this guy, let's look at the smaller one there, if that side, let's just say this side was 2, well, I know the ratio is 8 to 3. So if I'm going to fill in a proportion here, and I know that this smaller side is 2, so I'm going to plug in a 2 and an x, and I'm going to cross multiply and divide. Nothing big. This is the same thing we've been doing. So we just take 2 multiplied by 8, that's 16, divided by 3, bam, that gives you that side right there. Okay? Not that big a deal. So on this next one, we've got 6 to 10. All you're doing is comparing 6 to 10. What's the ratio? 6 to 10. Well, that's for perimeter, but don't forget to reduce. So this becomes 3 to 5. All right? Now for area, remember what you do with area? It now would be 3 squared to 5 squared. So this would be 9 to 25. That would be the ratio. So it's like saying if the area here was 9, what would the area be here? 25. 9 to 25, because this was 6 to 10, or 3 to 5. Find the ratios here of number 3. I'll let you do that on your own. All right, did you remember to simplify? Again, you're taking the 9, comparing it to the 12, so it's 12 to 9. Reduce it for the perimeter. Don't forget to simplify your ratios. And then square it for the areas. And let's look at this one. You get 2 picture frames that are similar. The ratio of them is 4 to 5. What's the ratio of the areas? Remember how you find the areas? Well, if the lengths are 4 to 5, how do you find the ratio of the areas? It's simple, remember? All you do is just square it. All right, you figuring it out? We're just looking at ratios here. We're just comparing it. So when we're comparing the perimeter, no different. It's just this number compared to the corresponding number on the other shape. 8 to 3, 6 to 10, 12 to 9, simplify it. But with the areas, you have to square it. So 8 squared to 3 squared, 6 squared to 10 squared, 12 squared to 9 squared, 4 squared to 5 squared. 4 square, sweet. It all comes back, doesn't it? All right. Well, that's it pretty much for today. There's your answers if you want to check them over again. That's pretty much it for today. Can you answer this question of how the size is affected by its area and perimeter? I bet you can. Why don't you do that now? Well, thanks for joining me here today as we talked about perimeters and areas and similar figures and how they're affected when you're doubled, quadrupled, all that. Just marvel in the greatness of this 4-square champion right here. Pretty sweet. All right, guys. Thanks for joining us. This was Matt with mathsmath.com. Check us out on Facebook at Solving Maths Problems and on Twitter at Maths Math. Enjoy math.